Hello everybody. I was designing this wireless charging PCB, and this would be the driver. There will connect the coil and condensators, capacitors. So it's based on H-bridge drivers. Like there will be two driver circuits, and this is driven by PIC microcontroller. It's sdPIC33J or something. And I was using PIC3 to program it, and at the beginning the programmer said that the target device consumes more energy than it can deliver. So I was started looking for the problem, and apparently I found out that this will be 12-volt power connection jack, and for PIC 33 there will be 3.3 volt power supply is necessary, 3.3 volts. So basically here I put in 3.3 volt regulator and some filtering capacitors, but the problem is that I didn't thought of creating here a jumper or a switch or some other connection type that I can switch it off if I'm just using a programmer, if I if I power the PIC from the programmer. So in this case I connected the circuit to the permanent power supply, and it consumes more than 1 ampere. So 3.3 volt was the voltage I set, and it consumes like 1 ampere. So I was surprised, and then I started to look at the issue, and as it seems in this little LDO, the problem is that inside this LDO low voltage dropout converter there is like two resistors in series to the ground, which sets the reference voltage according to this output voltage, which is necessary, in this case 3.3 volts. So basically what does mean? It means that there is constant resistance from this pin to ground, and if I connect the 3.3 volts to this pin, which is 3.3 volt pin, power supply pin, it consumes the power goes here to PIC as well as here, and here it goes directly to ground. But I think there is more problems with this, because the resistance was 3 kilo ohms or so. So it's not a big deal. There would be just a tiny power. So there is also some power transistor inside, and maybe some diode. So basically I realized that this is not a good solution, and what I need to do, I need here to put some kind of switch or some kind of other breaking point where I can, if I'm programming with my PIC tree, I can like open this circuit, and the 3.3 volt regulator stay its own. It's not supporting the PIC anymore. Yeah, so this is a little tip for others who is designing some kind of similar circuits or other circuits with a controller, PIC microcontroller for example. So yeah, basically the problem was this bad design, that I didn't think of putting here some kind of jumper. Yeah, and this circuit still is in developing process, and I was testing just a blink, and I guess in next week I will start to add some coils and using the power power transistors here and see what's going on, the frequencies and the efficiencies and so on. And this big one is actually it's the current shunt resistor, and there is a little chip which measures the voltage drop across this resistor, and through I2C it sends the chip the value of this resistor as well as voltage and as well as power. Nice. So thanks for watching, see you next time.